Okay, and this is the main function. First we are creating a first polynomial, calling the function create poly, and we are passing a variable is poly1. Here we created the different variables. Node poly1 is a one pointer variable initialized with the null, and poly2 is the another variable which is initialized with again null, and poly3 is the another third variable which is initialized with null. Okay, actually this is not required, poly3. Okay, because while adding the polynomial itself we will get the output. Okay, we need not to display the polynomial again. This code is actually showing a polynomial while adding the polynomial itself. Okay, so first we are calling the create poly function, which enters the first polynomial, and create poly function to enter the second polynomial, and display the first polynomial expression and display the second polynomial expression. And next we are calling the add polynomial, add poly, which passes with the two parameters poly1 and poly2, and shows the result of the polynomial addition. Okay, so I will see how to check this, execute, and how to check the addition. Okay, enter first polynomial, initially give the s, that is y. Enter coefficient, say for example I am giving a coefficient as 3 and power as 4, that is 3x power 4. Okay, so next again it asks for, do you want polynomial node s. Okay, I want to enter the second one. So 5 and 2. 2 is the power exponent. And third one, again I am giving a third one, 7 and with the exponent as 1. That is 3x power 4, 5x square and 7x. Okay, these are the three values in the first polynomial. So I want to stop the first polynomial. So close the first polynomial. And now it asks for the enter the second polynomial. S. Enter the second polynomial. Okay, second polynomial coefficient is 2 and exponent is say 5. And next for the second node, okay, second one 6 and power is the 3. Again another one, okay, 8 and power is the 2. Okay, so again another one is 9 and power as the 1. Okay, here you just observe that. Okay, so first polynomial is 3x power 4, 5x square, 7 power 1, 7x. And second polynomial is 2x power 5, 6x power 3, 8x square and 9x. So here compare the same polynomials. Okay, here we have two nodes with the same powers, 2 and 1, and here also we have 2 and 1. So these two are added. Okay, and remaining all are, okay, first it checks the first node exponent is 4, and within this second polynomial first node exponent is 5. So 5 is greater than the 4. Okay, so okay, this 2x power 5 is added as the result, added into the result. Okay, so it moves to the next node, that is 6. Okay, so now it checks the 6 coefficient node exponent, that is 3, and it checks with the 4. Okay, here it doesn't increment it. Here it is on the same node, 3x power 4. So here it is incremented to the next node. So 3 is less than the 4. So 3x power 4 is added into the result. Okay, so next it is incremented to the 5. Okay, now it checks the 5 node power is exponent is 2. So 2 is checked with the 3. Okay, 3 is greater than the 2. So now 6 3 is added into the result. Okay, first 2x power 5 is added, next 3x power 4 is added, next 6x power 3 is added into the result. Okay, so now 5x square is compared with the 8x square. Here the two exponents are same. 2 exponents are same. So 8 plus 5, 13. 13x square is added into the result. Okay, both are incremented here. So it increments to the 7 value, and in the second polynomial it increments to the 9. Okay, now again the powers 1 and 1 both are equal, so 7 plus 9 is a 16. 16x is added to the result. Okay, check the result. Okay, now stop the second polynomial. Okay, so your resultant polynomial is, okay, within the first these two, the 5 is greater than 2x power 5, and next within the 3x power 4 and 6x power 3, 3x power 4 is greater than, so 3x power 4. Next 5x square 6x cube, 6x cube is greater than this, so 6x cube. Next 5x square and 8x square both are same, so 13x square. Next 7x and 9x are equal, so that is x powers are equal, so 16x power 1. Okay, okay, there is a small problem with the plus symbols. Okay, so you can remove the plus symbols in the display so that you will get the only one plus symbol. I have given more than once, I think. Okay, so here this is the execution of the polynomial addition. Okay, if you have any doubt in the addition of the polynomials, you can check once this figure. Okay, so here you have two polynomials. Okay, one polynomial is 3x power 4, 2x power 8, 1 with a 1 constant. Second polynomial is 8x power 14 minus 3x power 10, 10x power 6. So now first it checks the first polynomial first node and second polynomial first node. Both the powers are equal, 14, 14 powers are equal. So 3 plus 8, 11. And this exponent is added into the result. Okay, if these two, now here these two are equal, so coefficients are added and added into the result. Okay, so now here it moves to the 2 node and this polynomial moves to the minus 3 node. Now these two are compared. Okay, 2, 8 and 3, 10 are compared. 10 power is greater than the 8. So this minus 3 and 10 is added into the result. Okay, so here these two, within these two, this power is, second polynomial power is greater than the first polynomial power. So second polynomial is added into the result. So now the P2 polynomial is moved to the next node. So it moves to the 10. Okay. So and P1 is on the same node, 2 and 8. And this is moved to the 10 and 6. Now 10, 6 and 2, 8 are compared. Okay. 10, 6 and 2, 8. These two. Okay. 2, 8 and 10, 6 are compared. So 8 is greater than the 6. So 2, 8 is added into the result. 2, 8 is added into the result. Okay. So now check this. This polynomial is completed. The second polynomial is completed. Okay. So because there is no next node after this. Okay. So and here it checks the 2, 8 is added into the result so that it increments to the 1, 0. 1, 0 node is incremented. So now it checks with the 0 and 6. 6 is greater than the 0. So 10, 6 is added into the result. Okay, 10, 6 is added into the result. And after that, the second polynomial is completed its nodes in the linked list. So it reaches to the null. So now the remaining nodes in the polynomials, that is P1 polynomial has one more node, that is 1, 0, that is directly added into the our result. So you have a result as 11, 14, 3, 10, 2, 8, then 10, 6, then 1, 0. Okay. Okay, this is only possible whenever you are giving a polynomials with the decreasing order of the exponents. Okay, if you are giving a random order of the exponents, then you need to sort the nodes with the exponent order. Either in the increase or decrease order, you need to sort. Then you can do the addition. Okay, without the having of exponents in a particular order, we are not able to find out the this addition of the polynomial. So this you must be remember. So while entering the polynomials, you must be enter the, okay, for our example, you must enter the polynomials exponents in the decreasing order. Okay. Okay. So just once go through this program and execute it. Then you will better be understood this program. Okay. Hello students. Okay.